In the triangle OPQ, OP is equal to P, QO is equal to Q, QS is equal to 2 over 3 QP, and OR is equal to K times OQ. Find in terms of P, Q, and RK, simplifying where possible, the vector QP. Now, what is the vector QP, right? What does that mean? Well, QP means that we start at Q and we end at P. And so if we have this here, we start at Q and we end at P, all right? So that means that we're gonna go from Q to O, right, in this direction. And we're gonna go from O to P, all right? Now, and that's why we have QP is equal to QO, right? Which we have QO, and then we go from O to P, right? So we go from O to P. Now, what is QO? Well, QO, they said it right there. QO, where is it? Where is it? QO, yeah, right there. QO is equal to Q. That's what we know here. QO is equal to Q, so let's put that there. QO is equal to Q. And we have it right there on the diagram. QO in this direction, QO is equal to Q. So that's Q. And then what is OP? Well, OP, we have it right there. OP is equal to P, right? And that makes sense because if we look at the diagram, OP is equal to P, right? So OP is equal to P. So that means that QP, that means that QP is equal to Q plus P. And that's the answer to this question. Next, we have to determine what is QS, right? QS. So QS means that we have to, QS means that we have to start at Q and we have to end at S. That's what QS means. We start at Q and we end at S. That's what QS means. Okay, so what does that mean? Like how are we gonna go about doing that? Well, what did they tell us about QS, right? They tell us explicitly that QS is equal to 2/3 of QP. So 2 over 3 multiplied by QP. So QS is equal to 2 over 3 times QP, all right? And that's what QS is. It's 2 over 3 multiplied by QP. But we know what QP is. We just figured that out in the previous question. QP is actually equal to Q plus P, because QP is Q to O, which is Q, and O to P, which is P. So QP is actually equal to Q plus P. So that means that QS is equal to 2 over 3 multiplied by Q plus P. Okay, let's move on to the next question. We have to figure out what is OS. So what does OS mean? Well, OS means that you start at O, right? And you end at S. That's what OS means. Now, in this case, what are they telling us? They're telling us that, okay, OS is going to be equal to OQ, right? And then QS. Now, so OS is going to be equal to OQ, so OQ, so we go from O to Q, and then we're going to go from Q to S. And that makes sense because you can see it, O to Q, then Q to S. But the question is, what is OQ? Well, we know that QO, if we're heading in, let me use this arrow. If we're heading in this direction, OQ is actually equal to, if we're heading in this direction, QO is actually equal to Q, right? If we're heading in this direction, QO is actually equal to Q. But we're not going from Q to O, we're going from O to Q. So we're going in the opposite direction. So we're still gonna have Q, but it's not gonna be Q. It's not gonna be positive Q, it's gonna be negative Q. And so OQ, yes, OQ. So that means that OQ, let's make this clear. That means that OQ, right there, OQ is actually equal to negative Q. And that makes sense because we're going from O to Q. We're not going from Q to O, right? Because Q to O is Q, but we're going in the opposite direction. And since we're going in the opposite direction, we have to put this in negative sign. So it's going to be negative Q, okay? Now, what is QS? We just figured out what a QS was. QS is 2 over 3 multiplied by Q plus P. Okay, that's what QS is. And so what we have to do here is we're going to distribute. So we're going to say, okay, 2 over 3 multiplied by Q. And we have 2 over 3 multiplied by P. And so let's continue. So we say, okay, we bring the Q down, all right? And we have the 2 over 3 Q, and we have the 2 over 3 P. And that makes sense because we have 2 over 3 multiplied by Q, which is 2 over 3 Q. We have 2 over 3 multiplied by P, which is 2 over 3 P, all right? Next, we have Q plus 2 over 3 Q. I'm sorry, we have negative Q plus 2 over 3 Q. Again, we have a negative Q plus 2 over 3 Q. And so what we're gonna do, what is negative Q? Well, the coefficient actually is -1. So we actually have -1 Q plus 2 over 3 Q plus 2 over 3 P. Now we could work and operate on the Q's. So we have -1 Q plus 2 over 3 Q. And so if we just focus on the coefficients, we actually have -1, right? Plus 2 over 3, all right? And what is that? That we can write that as, this can be written as, so we have a -1 plus 2 over 3. And so what we basically have is, we could write this as 2 over 3, right? Minus, right? Minus 1, right? We just switch it, right? So -1 plus 2 over 3 can be written as 2 over 3 minus 1. Now what is 1? Well, 1 is a whole, so we can say, okay, this is 2 over 3 minus a whole, which is 3 over 3. And so we have the same denominator, so we could subtract the numerators. What is 2 minus 3? Well, 2 minus 3 is -1, right? So it's going to be -1 over 3. And so that means that -1 plus 2 over 3 is actually equal to -1 over 3. And so if we have -1Q plus 2 over 3Q, that means that it's going to give us -1 over 3Q, all right? And that's because -1 plus 2 over 3 is -1 over 3. So -1Q plus 2 over 3Q is equal to -1 over 3Q. And we just put the positive 2 over 3P. Now, what else can we do? Well, we can factor something out. We can say, okay, well, I can factor out a third out of this, right? Because if you notice carefully, it makes sense, because if you notice that we can say, okay, if we factor out a third, we know that we can multiply 1 over 3 by -Q, right? And that's how we get -1 over 3Q. And we can multiply 1 over 3 by positive 2P, and that gives us 2 over 3P. So these two are saying the exact same thing. So this is the factored form of the one on top. Again, 1 over 3 multiplied by -Q gives us -1 over 3Q. And 1 over 3 multiplied by 2P gives us 2 over 3P. We can also switch what we have inside this bracket. And so we can say, okay, OS is equal to 1 over 3, right, multiplied by 2P minus Q. And we just do that so that we can have 2P out front, and we could have Q, we have the minus Q in the back. So we just switch the way how they are rearranged, just so that we can have the 2P in the front of the -Q, all right? And so we have that the answer for OS, the vector OS, is a third multiplied by 2P minus Q. And that's going to be helpful, especially when we move on to the next part of this question. Okay, so next we have RS. What is RS? Well, RS is actually equal to, well, what does RS mean, first of all? Well, RS means that we start at R and we end at S. Okay, well, how do we do that? Well, we can go from R to O, right? From R to O, then we're gonna go from O to S. Go from O to S. And that's good because we know what OS is. We just calculated what OS is, right? But what is RO, right? What is RO? Well, we can switch the letters. It's fine to switch the letters. We can switch the letters. Instead of having RO, we can have OR. And the reason why we want OR is because, well, we know what OR is. We don't know what RO is, but we know what OR is. So we're going to switch the letters. And so when we switch the letters, instead of writing RO, we write OR. But there's a penalty for switching the letters. The penalty for switching the letters is you have to put a negative sign in front of it. And so you can switch the letters, that's fine, but you have to put a negative sign in front. So RO is actually equal to negative OR. And so RS is equal to negative OR plus OS. Okay, so what is OR though? Well, OR is equal to K times OQ. That's what OR is. OR is equal to K times OQ. That's what OR is. OR is equal to K times OQ. And so we have negative, this negative outside, O front, because we have to put the negative, multiplied by OR, but what is OR? K times OQ. So we have K times OQ plus OS, all right? Next, what is OQ? Well, OQ is equal to negative Q. That's what OQ is. OQ is equal to negative Q. That's what OQ is. And we know that because if we notice carefully, if we go from O to Q, right? If we go from O to Q, well, that's in the opposite direction of this Q. So since it's in the opposite direction, then that means you have to negate. You have to put a negative Q, all right? Because QO, right? QO, if we just do, let me erase this. Let me erase this so you could get an understanding of what's happening. So notice that if we're going from Q to O in this direction, right? From Q to O, that's Q, right? That's this Q, right? But we're not going from Q to O, we're going in the opposite direction. So we're going in the opposite direction. We're going from O to Q. And since we're going from O to Q, we have to, and we're going in the opposite direction. We have to put that negative sign to indicate that we're going in the opposite direction. And so that's why that OQ is equal to negative Q. And so we have K times negative Q in the brackets, and we have the negative sign out front, and we have plus a third, open bracket 2P minus Q. So we have K times negative Q, which is here, and this is going to be plus a third 2P minus Q. All right, next, what are we going to do? Well, we multiply this negative one out front by, well, first, even before we do that, we say K times negative Q. And K times negative Q is negative KQ. Let me show it properly. So what we actually did was we say, okay, this is negative, open bracket, K, open bracket, negative Q. So what we actually did was we said, okay, what is K times negative Q? Well, K times negative Q is negative K Q, all right? But we still have O front, we still have a negative sign, And we know that a negative times a negative is a positive. And so that means that this is gonna be equal to just KQ. Okay, so that's just KQ. And so that's what we have. So we have just positive KQ here. So we have KQ plus, now what do we do with the OS? Well, the OS, remember from our previous question, OS is a third 2P minus Q. And so that's what OS is. And so what we do here is we say, okay, well, we have KQ plus a third 2P minus Q. Okay, so, and let me just leave it like that because we have RS is equal to KQ plus a third 2P minus Q. And that's our answer for this question. All right, so moving right along, we have this next part. It says, okay, calculate the value of K, figure out the value of K. Well, what's the hint? Well, they give us it. They tell us that RS is parallel to OP, right? So RS is parallel to OP. And so with that understanding, they want us to figure out what is the value of K. Now, okay, so we know that the vectors RS and OP are parallel. What does that mean? Well, if two vectors are parallel, that means that they are scalar multiples of each other. And so if two vectors are parallel, this means that there exists a real number. Let's call that real number n, right? Such that we can take this real number n and multiply it by OP, and we can get RS, okay? Which means that they are scalar multiples of each other. So we can take n multiplied by OP, and we can get RS, okay? So what is RS? Well, we just figure out what RS is. RS is equal to KQ plus a third 2P minus Q. And what is NP? I'm sorry, what is OP? Well, OP is simply equal to P. And we know that because if we go back to our diagram, OP, right? OP is just equal to P, all right? And so that's what OP is. OP is simply equal to P. And so we have that RS is equal to KQ plus a third 2P minus Q, and that's going to be equal to N times P, because OP is P, okay? Next, we have to, we're going to expand this. So we have a third multiplied by 2P, and a third multiplied by 2P is equal to 2 over 3 times P. Again, a third multiplied by 2P is equal to 2 over 3P. And then we're going to take this a third, right? Let me use a pen. We're going to take this a third and we're going to multiply it by negative Q. And so we have a third, right? We have a third multiplied by negative Q. And that gives us negative a third Q. And that's going to be equal to 0Q plus NP. Now, the reason why I put 0Q is because notice that we have NP, right? So we have a term that has P in it on the right-hand side. But if you look on the left-hand side, we have terms that have P and Q. All right. So we say, okay, well, let's just write 0 times Q so that on the right-hand side, we'll have a term that has Q in it, and we have a term that has P in it, okay? Now remember that these two sides must be equal. And so if these two sides are equal, then let's, on this side, what I did here, I said, okay, let me group together all my terms that have Q in them. So KQ has Q, and a third and negative 1/3 Q has Q in it. So we have KQ minus a third Q, and then we have 2 over 3 P, okay? And so we have 0Q plus NP, all right? Now, what I did here was I said, okay, well, can we factor out this Q, right? So can we factor out this Q? Can we just have Q on the outside and something in the inside? And it is true, we can factor out the Q because we can take out the Q and put it there. And what we have left? Well, we have K minus a third. Because if we say Q, and we multiply it by K, that's KQ. And if we say Q multiplied by negative a third, that's going to be negative a third Q. And so this expression can be written as K minus a third Q, okay? And we put plus 2 over 3P. And that's going to be equal to 0Q plus NP. Now, what we can do is we can compare the coefficients of P and Q. So this right here, this term is the coefficient of Q, and 2 over 3 is the coefficient of P. And on the right-hand side, the coefficient of Q is 0. So this is 0Q. And on the right-hand side, the coefficient of P is N, all right? And so if we compare these coefficients, right, we'd have, right? So what we're basically doing is we're comparing. So we're saying, okay, this term, right, has to be equal to this term right here. These two terms, these two coefficients must be equal. And the reason why we say that they must be equal because they must be equal because this right here is the coefficient of Q, and this right here is the coefficient of Q. And we know that these two sides are equal. So if these two sides are equal, that means that the coefficient of Q on this side has to be equal to the coefficient of Q on this side, okay? And that's why it's important for us to put on the right-hand side the Q, a term that has a Q in it and a term that have a P in it, because we are actually going to compare the coefficients of these terms. So it makes sense. So if we know that these two sides have to be equal, then it makes sense that if we have a term that has a coefficient, and it makes sense that, okay, so if we know that these two equations are equal, if we know that these two sides are equal, if we know that this side is equal to that side, then it makes sense that the coefficient of Q on this side must be equal to the coefficient of Q on this side, right? Because the two sides are equal. And so the coefficient of this Q must be equal to the coefficient of this Q. And so that's why we have K minus 1 over 3 has to be equal to 0. And the same thing is true for P, right? If these two equations are equal, that means that the coefficient of P on this side has to be equal to the coefficient of P on this side, right? Because the two sides are equal. So if we have a coefficient of P on this side, it has to be equal to the coefficient of P on this side as well. All right, and so that's the logic, that's the idea behind it. And so what we have? We have 2 over 3n, right? And then we have K minus 1 over 3, which is equal to 0. And so that's good because we have the formulas, or we have the equations. We know explicitly that n is equal to 2 over 3. But we didn't need to figure what n is. That's not what the question asks us for. The question really wants us to determine what is the value of k. And so in order for us to figure what is the value of k, what we're gonna do is we're gonna say, okay, well, let's take this a third, this negative a third, we send it over the equal sign, and it becomes positive 1 over 3. So that means that k is equal to 1 over 3. So the value of k, if we know that RS and OP are parallel, the value of k is going to be equal to a third. And that's the answer to this question.